All righty. So this is kind of what I was talking about here. Okay, because the natural logarithm is undefined for negative numbers, you'll often encounter expressions of the form the natural log of the absolute value of u. When you differentiate functions in the form y equals natural log of the absolute value of u, do everything as usual. Okay, I'm not going to bother reviewing what we've done, what we did earlier. I feel like I guess I do want to highlight one thing here. I will review some of our logarithm properties for you guys also, maybe at the end of the notes here, just to kind of refresh your memory a little bit. Because something like this, right, in letter B, you look at that and you're like, that looks like an awful derivative to take. But remember that our logarithm properties, right, allowed us to break it up so that when we had a product, we could change it to addition between two logarithms. When we had division there, a quotient, you could change it to subtraction. And then that makes it much more palatable for taking the derivative and stuff like that. Okay, you may absolutely use those logarithm properties tomorrow if if you can, right? If you're able to, you may use them, of course, to help you out. Feel free to simplify as much as you can. Okay. But anyway, so going back to this, right? Taking the natural log of the absolute value here of 2 sine squared x plus 3. Actually, we want to write the equation of the tangent line. So again, could be a kind of question you see tomorrow on the quiz. All right. To write the equation of the tangent line, what two things do we need? Slope and a point. Okay. Do we have either of those two things in this particular problem? Yes, kind of. What do we kind of have so far? A point. But do we have a point? We have an x-coordinate. We don't have a y-coordinate, though, right? So we have two things we need to do. We need to figure out the rest of our point, right? And we also need to figure out the slope. All right, let's do the slope part first. How do you find the slope of a tangent line of a function? Take the derivative. Okay. There's no real simplification we can do here. Addition in a logarithm, there's no property to break that up. Addition in a logarithm, there's no property to break that up, so we must leave it the way it is. Okay? So what rule are we going to have to use here when we go to take the derivative of this function? Do we need to use the product rule, for example? Is this natural log times 2 sine squared x plus 3? No. What rule are we going to use? Chain rule. Okay, so think about layers, right? What's our outermost layer that we will be taking the derivative of? What's our outermost function here? The natural log. What's the derivative of the natural log of something? 1 over that something. So it'll be 1 over 2 sine squared x plus 3. Okay. So we took care of the natural log, and then we multiply by the derivative of what is inside that function whose derivative we just took. So we just took the derivative of natural log. We're going to multiply by the derivative of this. Okay? So let's focus on this since it's like two pieces, right, by addition. Let's focus on the first piece right here. What are we going to take the derivative of first for this? Something squared. Something squared, right? The sign is being squared here. If you need to help you kind of see all the layers at play, consider rewriting that sine squared of x as sine of x quantity squared plus 3 like that to kind of see, yes, the sign is being squared here. So when we go to take the derivative, we bring that 2 out front. 4 times sine of x stays the same, okay, times then the derivative of what was inside the square. The derivative sign is cosine of x. Okay, and I guess I should put a parenthesis here because we're multiplying by what's inside. Okay. Plus the derivative of 3. What's the derivative of 3? 0. And so there is our derivative. Okay, there is our derivative. All right, so again, one more time, going through it, right? Derivative of natural log of something is 1 over that something. 1 over that something. Okay? Times the derivative of what was inside. So that 2 sine squared x plus 3. So the 2 for the sine squared goes out front, making 4. Sine x stays itself because it was inside, and then you multiply by the derivative of sine of x, cosine of x, derivative of 3, 0. Okay? And so there's our answer. All right? So we've got the derivative. Now what do we do to find the slope of our tangent line? Plug in pi over 4. Bless you. Okay, so we plug that in. And then we evaluate. Tomorrow, by the way, no calculators. No calculators on tomorrow's quiz. Okay, so don't forget your trig stuff, right? Bless you. Sine of pi over 4 is root 2 over 2. Squared, though, will be 2 over 4, which is 1/2. Okay. Sine of pi over 4 is going to be root 2 over 2. Cosine of pi over 4 is also root 2 over 2. Okay. And so we get, let's see, 2 times 1/2 is 1, plus 3 is 4, so it's 1/4. And then root 2 over 2 times root 2 over 2, it's going to be 4, 2, 4 is 1/2, so 4, 2. So 1/2 is our slope. Okay. So we've got our slope for our tangent line. Yes?
All right, so going all the way back up to the
Sure.
top.
Right here?
Yeah, so for the 4 times sine of x times cosine, why wouldn't it just be 4 cosine?
Because we have let's look at this maybe, right? You agree that this right here, the original, is the same as this thing, right?
Yeah.
That's what that's saying. So you'll see that sine of x is inside the square, so we have to apply the chain rule. So the 2 goes out front for sine, and then times the derivative of what's inside cosine. Yeah, that is like a
Yeah, okay.
that's not trivial to see that, right? I mean that's pretty tricky there. Okay, but that's there. Okay, so there's our slope. What else we still have to do? We have to find the y-coordinate, right, for our point here. We've got the x-coordinate, pi over 4. We're going to plug it in. So f of pi over 4 now, to find that matching y-coordinate. Well, yeah, we did the derivative. Yeah, now we got to find the y-coordinate. So natural log of the absolute value of 2 times the sine squared of pi over 4 plus 3. Okay. So again, sine of pi over 4, root 2 over 2, squared is going to be 2/4 or 1/2. 1/2 times 2 is 1, plus 3 is 4, and so you get the natural log of 4. Okay? And so then our point slope form would be y minus our y-coordinate there, natural log of 4, equals m times x minus our x-coordinate. Okay. Now, you don't have to simplify, and I've told you that in the past. So what you could have written for the equation of your tangent line and point slope form, this is absolutely okay. You could have written okay, you also could have written this, and I would still give you full credit there. So would the AP test. Okay? You don't have to simplify arithmetic. All right? So if you get, if you're unsure and you don't want to potentially lose points or something like that, I got to be careful here that I make sure. Well, I guess that would still be okay, but I'm going to do this just because. Okay. So that is absolutely acceptable. Okay? When you get down to the point where all it is arithmetic simplification, including evaluating trigonometry and natural logs to a certain degree there, okay, you may stop there and say that's my answer. Okay, and that is a sufficient answer. Okay, that is sufficient. So, I don't know if that's helpful or not, but there it is. Okay, it's still kind of messy, but there it is. All right, questions on anything there from example 8? And urgency, see, I can get you guys the paper here if you wanted to, so that way you can see it later. And we can talk through it too later if you want to as well. Sure. Okay. All right. Let's move on then to example 9. Example 9 is multiple choice. So y'all go ahead and give it a shot. A, B, C, or D. This is actually taken from an AP test, okay, a past AP test. So there's an example of a question that you might see, okay? So there are some kind of naked problems, without context or anything like that on the test. So give it a shot. potentially.
So then you'd square pi over 4.
You'd square the pi over 4.
Find the sine.
But of course, we wouldn't be able to do that because we don't know what sine of pi squared over 16 would be. So that'd be a calculated problem at that point. So we have functions within functions here for this one. So be careful making sure what you got there. Oh no. I'm so sorry. Do you want another one? I do have a spare one probably. So the Danish student had, so. Yeah, well. Right, I mean, what would he do? I mean, exactly, so.
Wait, I see.
Oh, it's the derivative of what was inside. What was inside was 2x. It's like those full derivative. You're almost there. And then simplify. Back in the day. No way. See, it's not so wrong. I do. So watch with your derivative there. Yes. So you have 2 there in the numerator, cancel the denominator.
Isn't that crazy?
Nope. Is that what you said? Yeah.
Really bad.
Yeah, but
And then
there's
Right, let's just all over that. Yeah.
So this is so the reason what are you talking again about?
Yeah.
that's really
Again, exactly right. Exactly right. Okay, folks. So, if you got C, if you got C, you were close, but you missed one more application of the chain rule. If you got C, you were close, but you missed one application of the chain rule. So, let's tackle this here real quick. We've got sine of the natural log of 2x. Okay? So you can see all the layers here, right? First, we're going to take the derivative of what? The outer function, which is in this case sine. So derivative of sine is cosine. Leave what's inside alone. So just cosine. Everything else inside stays the same. Times the derivative of what was inside. Right? So what's inside here is the natural log of 2x. What's the derivative of natural log of something? 1 over that something. So 1 over 2x times the derivative of what was inside the natural log, which is 2x. So derivative of 2x is 2. Okay. And so then, to simplify this, and so Morgan, if you just want to see here, right? So this, you can consider this to be a fraction. If I wanted to make it a fraction, I'll just put it over 1, right? Put this over 1. So 1 times 2x times 1, 2x in the denominator. Cosine natural log 2x times 1 times 2, that's in the numerator. The 2's I can cancel and simplify, though. And so it's going to end up with the b. Okay? It's all one product, so it's nice to just combine it all together there. Okay, so it is b. Questions on any of that? Okay. So again, right, multiple choice, it's nice, the answer's right in front of us, but it's bad because they also have common mistakes in front of you too. That will, if you go a certain path, it'll lead you to those incorrect answers. So just be careful there. All right. Last little derivative that we need to learn, okay, this is for derivatives for bases other than e, okay? We don't, so we didn't talk about 2 to the x or 5 to the x or anything like that. So let a be a positive real number, okay, a not equal to 1, and let u be a differentiable function of x, okay? If we want to take the derivative of a to the x, that is a to the x again, so it's like, wow, that's just like when we take the derivative of e to the x, right? E to the x, it's e to the x, but then we also have the additional natural log of the base, which if you think about it for e, this rule also applies to e, right? Because if I do the derivative of e to the x, it's going to be e to the x times the natural log of, well, e in this case is my base, but what's the natural log of e? 1, and so that's why we end up with just the e to the x there. Whereas here, right, it could be like 2 to the x, and so the derivative of 2 to the x would be 2 to the x times the natural log of 2, right? Natural log of 2 does not simplify so nicely. All right, and then of course it's, kind of like companion here is for the chain rule, right? If you have a, like 2, raised to a function, then it's a to that function again times the natural log of your base a times the derivative of the function, right? Using your chain rule there, times the derivative of what's inside. Right? So looking at letter A, for example, here, this is going to be an application of the chain rule. We have 2 raised to a function. So dy dx, okay, is going to be equal to, we'll say 2 to the 3x again, times the natural log of 2 times what? 3, right? The derivative of 3x, 3. Okay, just like that. Okay, just like that. Questions on any of that? Okay, last one here, letter B. Letter B. Okay, x to the 4th times 4 to the x. When we go to take the derivative of this, we will need to use product rule. Good. We've got 2 things being multiplied together here. And so it'll be the second times the derivative of the first plus the first times the derivative of the second. So 4 to the x times the natural log of 4 times 1 if you want to, right? But it's not really necessary. The chain rule there, it applies, but it's not, it's just kind of a trivial chain rule application there. Okay. Questions on any of that? Of course, here we, so I guess I could have done some, there's some kind of simplification you could do here. You could rewrite it as 3 ln 2 times 2 to the 3x. Here we could there's a GCF of 4 to the x and x to the 3rd, it looks like. And that would leave us with a 4 there plus x ln 4. Something like that. I don't know if it's super necessary, but there it is. Okay. You could do a little bit more with this too, if you wanted to. Remember that 2 to the 3x, right? If we kind of use our exponent properties in reverse, that's the same thing as saying 2 to the 3rd times. Oh wait, never mind. 2 to the 3rd to the x. So never mind. I was going to do something very bad there. Never mind. That's what we're going to keep it as. We can't break it up because it's only if there's addition could we break it up using multiplication. So sorry, let me show you what I was about to do here. 2 to the 3 plus x is equal to 2 to the 3rd times 2 to the x. But 2 to the 3x is only equal to 2 to the 3rd raised to the x power. So here it would have been helpful if it was 3 plus x, but since it was just to 3x, then you can't really do anything else there. It's just going to be 8 to the x. I'm not that sure if that's helpful or not, but anyway. Whew. All right, careful, Mr. Whitmire. All right, so there we go. All right, simplified. So questions on any of that? That's it. So now we've seen everything that you could potentially see on tomorrow's quiz. All right. Again, you'll have some choice on tomorrow's quiz. And again, I'll talk urgency with you about that in case, I don't know if you guys got all that stuff, so I'll let you know that too. Okay. I'll talk about logarithm properties here too, real quick, just in case, you're interested. I don't know, if you just want to squeeze it in somewhere on your paper. I don't know if we really got it, but I'll just throw it out there just so you can see. All right. So, basic properties of logarithms, right? Just so. Okay. I'm not going to do this very elegantly, but at least it will work. Okay. So so log base a of m times n is equal to log base a of m plus log base a of n, right? Oops, I want to do it this way. Log base a of m divided by n is equal to log base a of m minus log base a of n. Okay. Log base a of m plus or minus n. No rule. No rule. No simplification. Right, and then log base a of m to the n equals n times log base a of m. Okay, just as a quick refresher there of some of your properties. I guess I'll do one more. What's log base a of a? 1. 1. Okay. And what's log base a of 1? 0. Remember that a logarithm, in its in a basic fundamental sense, the logarithm is asking a to what power gives us a, or in this case, a to what power gives us 1, right? That's what a logarithm is kind of asking in a fundamental sense. So a to what power gives us a? Well, it's a to the 1, right? A to what power gives us 1? Well, it's a to the 0 gives us 1. Okay, so those are some examples right there. All right? That's true for all, of course, the natural log too. Natural log is just log base e. Right? Natural log is just log base e. So any of that, you could place all these logs with ln, right? And it'd still be the same thing. But keep that in mind right there. No rule there. Okay? So there's your quick refresher on logarithm properties. All right. Anything else? Questions on anything? All right. So, Mr. Goff.
Delivery.
Thank you. Thank you. Did you meant to have that there?
Yeah.
Okay.
Someone used the whiteout on the copy.
Oh, nice. What is the timing for tomorrow's quiz?
Between 0 and 80.
Oh, really? So you're giving them the full time?
No. Pick a number at some point.
Oh, okay.
Let me think about it for the end of the sentence. Let's say 35.
35 minutes? Okay.
No.
With all the derivatives and stuff like that?
That's 7.
Yeah.
2 second
9.
derivatives.
Yeah. Second derivatives are like 4, really. There's 2 of those.
PVA, 15 minutes, 2 minutes per problem. That's 30, 3 minutes, 3 minutes, 3 minutes, 3 minutes, 45.
45 minutes. Thank you, Mr. Goff.
Final answer.
Final answer. All right. Wonderful. He's very good at mental math if you've never had Mr. Goff before. So, anyway. Much better than I am. If you have me, you'll find out. But anyway, okay, so I will post the review, okay, and then, yeah, we can get started, okay? There is a homework assignment, too, that's already been posted, so if you want to work on the homework assignment, feel free to do that. If you want to just do the quiz review, feel free to do that, right? Tomorrow, there will be no homework assignment from the book. There will be no homework assignment from the book or anything like that.
What do you mean from the book?
I will explain that tomorrow.